Good morning, students. This video is going to explain about the single bus organization operation. Fetch the word from memory and store a word into the memory, which is a model number 5 of basic processing unit coming under the course Computer Organization and Architecture. Let us see what actually fetching the word from a memory. To fetch a word or instructions, a data from a memory, processor transfers required an address to MAR, nothing but memory address register. At the same time, what happened? The processor issues a read signal on control lines of the memory bus. When requested data are received from memory, they are stored in the memory data register. From memory data register, they are transferred to other registers. The response time of each memory access varies based on the catch miss or memory mapped IO. To accommodate this memory function complete is going to be used over there. So the processor waits until it receives an indication that requested operation has been completed by the memory, so that an MFC signal is going to be received from the memory to the processor. This MFC signal is sent from addresses device to the processor. So the memory complete or a memory function complete informs that the processor that the requested operation has been completed by addressed devices. Let me consider an instruction move R1, R2. How this sequence is going to be doing its operation to fetch a word from the memory. In general, if you're going to explain about that, it can transfer the data of this register R1, indirect addressing of register R1 will be moved to memory address register, and it's going to ask to start a read operation on the memory bus. Later, the processor has to wait to receive an indication that the requested operation has been completed or not, so that it needs to wait for a memory function complete response from the memory. Once this is going to be received, it's going to take the data and it's going to load the data into the data register, memory data register from the memory bus. Later, this particular memory data register, the content which is going to be present in the memory data register is going to be moved to the specified register R2. Such a way, it's going to move the content from the R1 register indirectly specified to the directly specified register R2. Let us see about this particular operation with the help of a timing diagram. So this timing diagram is going to be shown over here for read operation from the memory. We are going to have a series of clock pulses. Each and every clock pulse is going to be get specified, and when we are going to give the first instruction, move the indirect data which is going to be present in the particular register R1 is going to be moved to the memory address register during the first clock pulse, which is going to be doing its operation. It's going to do the transfer the data address. Next, the address is going to be specified and that is going to be get identified. Next, during that time, when address is going to be fetched, obviously the read signal is going to be get start. So here it's going to start a read operation on the memory bus. Later, when the memory is going to be doing its fetching the data, once the read instruction is given over there, the trailing edge is going to be used over to fetch the data from the memory. It may take some time duration to fetch the data from the particular respective memory location. And once the memory location data is going to be identified, then the data will be inserted from the external thing. MDR will be issued over there to fetch the particular input data. Then it's going to fetch the data, and once it's going to be fetched, the memory is going to give a signal that memory function completed from the memory to the processor. Once the data is going to be fetched, it's going to give the information as memory function completed. Then what happened? The memory data register, which is going to out the data. Such a way, what happened? It's going to load the MDR data from the memory bus, so that the MDR memory data will be moved to the register R2. Such a way, this fetch operation is going to get performed in this particular order. Okay, so here if you're going to see about that, the R1 out, comma, MAR in, comma, read, which decides the operation. How actually these operations are going to be get present over there. Let's we are going to discuss about that. R1 out, comma, MAR in, comma, read, which decides addresses is loaded into the memory, nothing but memory address register, and read command is going to be get issued. Later, which is going to load the memory data register from memory bus and wait for the memory function complete response from the memory. Later, the data R2 is going to be loaded from the memory data register. Here, if you're going to see about that, the control signal, which is the MFC, that causes processor control circuitry to wait for arrival of the MFC signal. Such a way, the fetch a word from the memory is going to be get completes with this particular timing cycle. Let's see about the next one. Storing a word in memory. Storing a word in memory is going to be nothing but writing a word into a memory, which is going to be memory location, which is going to be dealt in this particular area. Writing a word into a memory location is going to be following a few instructions. Let us consider about that one. Here, the storing a word in memory also follows a similar operation of fetch the word from the memory. The desired location is going to be loaded into the MAR, memory address register, and then the data to be written are loaded into the MDR, nothing but memory data register, and write command is going to be issued. Hence, executing the instruction move R2, comma, R1, which is R1 is going to be indirect addressing, which requires a sequence. Let's discuss about the sequence. So first one, R1 out, MAR in, which is nothing but a desired address is going to be loaded into the memory address register. Next one, R2 out, MDR in, write, which is nothing but which is going to write the data or data to be written or loaded into the memory data register, and later the write command is going to be issued. Then third one, MDR out E, WMFC. This is nothing but which is going to load the data into the memory location, which is going to be pointed by the register R1 from memory data register. So the write control signal causes the memory bus interface hardware to issue a write command on the memory bus. So the processor remains in the step 3 until the memory operation is going to be completed and an MFC signal, nothing but a memory function complete signal, is going to be get received. Such a way, the storing a word in memory is going to be get done in this particular sequence of instructions.